So good evening. So today I am going to discuss the computational technique of 2A and 1A, the 2A one observation parcel, Anova, and 2A more than one observation parcel, Anova. So please join. So this is the first example. So this is the first example. Hello. Please tell your friend to join. Okay. So uh, please write your name in the comment section. Okay. So okay. So good evening, everybody. This is the first example. So here I consider an experiment was conducted to determine the effects of different dates of planting and different methods of planting on the yield of sugarcane. The data below show the yields of sugarcane for 4 different dates and 3 methods of planting. So here we see that dates is one factor and methods is another factor, and the date has 4 labels and method has 3 labels. Okay, so and if you look at the data, then you see that every cell contains one observations. So it is a one-way ANOVA, two-way ANOVA, two-way because there are 2 factors. One is date and another is method. Two-way ANOVA, one observation parcel. Yes, Anushka. Good evening. Olumi, good evening. Two-way ANOVA, one observation parcel. Okay. So it is clear for you. So factor 1 is date and factor 2 method. And date has 4 label, that is October, level 1, level 2 November, level 3 February, uh, label. So I think there is a problem. Okay, please wait. Please tell me, can you hear me properly? Okay, follow me. Okay, okay, Korobi. Thank you. That is fine. Okay, that is fine. So I repeat this again. I already mentioned that this is a two-way ANOVA because there are two factors. One is date. Date has four labels. So label 1 October, label 2 November, label 3 February, label 4 March, and factor 2 is a method, and method has three labels. That is, here I use three methods: method 1, method 2, method 3. These are treated as label of method. So this is a two-way ANOVA, one observation per cell, one observation because each cell contains one observation. Okay. So first I denote observation. So please, there is a technical issue. Please give me a 2 or 3 minutes. Okay. So I think now it is fine. So I denote um, I denote Yij is a DA yield of sugarcane for the ith method. So for ith method and jth date. And I equal to 1, 2, 3 because there are 3 methods, and j equal to 1 to 4. 1 for October, 2 for November, 3 for February, 4 for March. So that Yij is the yield of sugarcane for the ith method and jth date. Okay, so the model is Yij equal to mu plus alpha I beta j plus Cij, where mu equal to general effect, alpha equal to additional effect, due to ith level of due to ith method, due to ith method. Okay, and beta j equal to additional effect due to jth date. Eij is a random error corresponding to ijth observation. Now add this, first you add all column total, is that tell me, I think it is 25 according to my calculation, it is 25.69. If it is okay, please tell me yes, and otherwise please rectify, please give me the correct solution. The sum of these three values gives 25.69. This one is a 12.06. Paulumi, Korobi, Anushka, Paulumi, please tell me these are correct or not. This is a 14.18, 14.18. This is 6.35. If these are correct, please tell me. And now this is row total. $17.39, 22.31, 18.58. So I denote column total by Pi naught is a sum over j from 1 to 4 Yij, where I from 1 to 3, then T1 naught is 15 point, sorry, T1 naught is a 17.39, .34. Yes, thank you. Please rectify this. This is 6.34. T2 naught, this is equal to 22.31. Follow me, tell me other portions are correct or not, other column totals correct or not, and also tell me the row total. What about the row total? Is these are correct or not? If there is any mistake, please tell me. T3 naught, this is equal to 6.34. Thank you, follow me for this. Next, define P naught j I from 1 to 3. I think I from 1 to 3 Yi j from 1 to 4. Okay, follow me. What about row total? Then T naught 2, this is 15 point, this is 15.69. Sorry. T naught 1 is a 25.69. T naught 2, this is 12.06. T naught 3, this is 14.18. T naught 4, this is 6.34. So please tell me, are you get same values or not? Follow me, Korobi, Anushka, follow me, please tell me, are you get same values or not? And G, we know G is a grand total. Second row is, okay, it is a 22.30. Okay, thank you. Thank you, follow me. 22.30. Please rectify this. Grand total, this is equal to double summation I from 1 to 3, j from 1 to 4, Yij, this is equal to 58.28 according to my calculation. Please tell me, is it correct or not? Or else you can just add up this or this. Please tell me, these values are correct or not. Anushka, Polumi, Porobi. Please tell me these values are correct or not. And n is a total number of observations. $58.27. Okay. This is 58.27. Total number of observation. This is equal to 3 into 4, that is 12. Okay. So can I go to the next slide? Follow me, please tell me. Actually, I observed that follow me only answered. Korobi, what about Korobi and Anushka? Please tell me. Can I go to the next slide? So one thing you can do it here, that is correction factor. I denote by correction factor by CF. So the correction factor. This is equal to G square by small n. And I think is 283.00465. Please tell me. One two 3.0465. Please tell me, is it correct or not? Then compute total SS. This is equal to sum over I from 1 to 3, j from 1 to 4, yij square minus cf. Please tell me this value. Then compute this is due to okay, follow me. This is 28294. Okay, so please rectify. This is 282. Follow me. Can you round it up to 4 decimal place? And then tell me the answer. Round it 4 decimal place and tell me the answer. 282.9. Then tell me the remaining 3 digits. Rounding up to 4 decimal place. This is SS due to method which is equal to Follow me? Are you hearing me? You round CF correction factor up to 4 decimal place. Up to 4 decimal place. Okay, 9494. Thank you. 9494. Then tell me the total SS. Please compute this. Then SS due to method, which is denoted by SSM, this is equal to sum over I from 1 to 3 Ti naught square by 4, okay, minus correction factor. And then compute SS due to date. SS means sum of square, okay. SS due to date, I denote this SSD, capital D, which is equal to sum over j from 1 to 4 P naught j square by 3 minus correction factor. Okay, follow me. SST is, okay, please do the remaining SSD, SSM and SSD. Please tell me these two. 72.5073. Okay, thank you. And we know total sum of square can be split into different component. So SST, it is better to write total SS equal to SST equal to that. So SST is equal to SSM plus SSD plus SSE. So this implies SSE is equal to SST minus SSM minus SSD. So please tell me this value. So please do it fast, okay. And the total degrees of freedom is -12 minus 1 is 11. Degrees of freedom for SS due to method is equal to, how many methods are there? 3 methods. So 3 minus 1. So this is equal to 2. And for date it is 4 minus 1. This is equal to 3. And SSC, error degrees of freedom, is equal to (11), because it is also using the additive property of degrees of freedom. You can write that error degrees of freedom equal to 11 minus 2 minus 3, which is equal to 6. So please tell me these values SSE, SSM and SSD. Please tell me the SSN and SSD. So write this page 2. SSP equal to SS 72.5073 with degrees of freedom equal to 11. SSM according to Paulumi, this is equal to, okay Paulumi, very good, 3.2802, and SSD is a 65.9465, and tell me the SSE, follow me. SSM 3.2802 with PF equal to there are 3 methods, so this 2, and SS date, SSD to date, which is equal to 65.9465 with DF equal to 3. So tell me the SSC. After computing this, if we need to compute mean sum of square, yes, thank you Paulumi, 3.2806 with DF 6. One thing you should note, if you after subtracting, if you get SSC is negative, then it is clear that your calculation, there is a mistake in your calculation, because sum of square always greater than 0. Okay, so after computing SST, SSM, SSD, SST, SSM, SSD, and using this, if you get SSC is less than 0, then you have to check your calculation. Okay, mean sum of square due to method MS mean square due to method. So mean sum of square due to method. Mean square due to method, which is SSM by corresponding degrees of freedom. Here it is 2. Please tell me, follow me. Anushka, what about please response? Okay, Anushka, please response. Porobi, please response. Then mean square due to date. Follow me, tell me what is the value of, what is is the value of MSN? Mean square due to date MSD, which is SSD by 3, and mean square due to error okay MS follow me, MSSME, not MSSME, MSM or MSME, not double S, okay, single S, mean squares MS, S for squares, okay. So this is equal to 1.6401. Thank you, follow me. Please tell me MSD, follow me. Mean square due to error, which is equal to SSC by 6. And we know for 2A Anova fixed effect model, MSC is the valid error. So F ratio for method is, I denote this by F1, which is MS M by MSC. Please tell me this value, follow me. MSD, okay. MSD according to follow me 21.9821. Thank you, follow me. And mean square error, okay, thank you, 0.5467. What about F1? F ratio for method for date, this is equal, I denote this by F2, which is MSD by MSC. Now we construct the Anova table. F1 is 3, only 3. Okay. I think you write 3.00. If you write in that way, that means we rounded it up to 4 decimal place. Okay. So first column is source of variance, source of variation. Second column is degrees of freedom. Third column is SS, sum of square. Fourth column is mean square, MS. This is F ratio. If level of significance is mentioned, then you compute critical value for that level of significance. Otherwise, since here level of significance is not mentioned, so we consider both level 1% and 5%. Okay. Okay. It is a 40.2087. Thank you, follow me. This is observed. You should write it of state. And critical value at 1% level and 5% level. For critical value, we can use a table. Any either any statistical book you can get this value, or from internet you can get a table, or you can use biometric table, or you can use statistical package. For example, R. If you use R, then you use code UF 0.99 for 1% level, corresponding degrees of freedom. DF1 here is DF1. If you interested in method, method, then degrees of freedom is 2,6, and round it up to 2 decimal places. So I write it R code, round UF 0.99, 2,6, 4. Okay, or you can use Excel also. And for 5% level, you change all except this, all are same. You use 0.95, that is round QH 0.95, 2, 6, bracket close, 4, bracket close. Okay. Here I consider, here I use 4 decimal, round all the digits 4 decimal places, all the numbers 4 decimal places. So I use 4. Otherwise, if you rounded it 2 decimal places, just change this 4 by 2. Okay, and in that way you can round it 3 decimal place, 5 decimal place, just change this. Okay, so from table, or if you use R code, in that R table there are maximum egg table, they rounded 2 decimal places. So from, if you look at the F table, then for 1% level, corresponding method, because for method degrees of freedom is 2, here SS is 3.2802, MSM, this is 1.6401, observe F 3, and then corresponding critical value for 1% value, that is 10.92, and for, if you use 5% level, it is 5.14, and date degrees of freedom is 3, SS is 65.9465, MSD, this is 21.9821, observe F, which is 40.2087, and corresponding critical values are 9.78 and it is 4.76. We see that, and the error is degrees of freedom is 6, this is 3.2806, and MSC is a 0.5467 total. Degrees of freedom is 11. 72.5073. Okay, this is the Anova table. Now, we see that the observed F for methods of planning being smaller than F 0.05 to 6, whose value is 5.14, and hence this methods of planning is insignificant at both the levels, because F 0.05 2,6 always less than F 0.01 2,6, because F 0.05 2,6 means upper 5% upper 5th percentile of F distribution with degrees of freedom 26, and F1 F 0.01 26 means upper 1 percentile point of F distribution 2,6. So it is obvious that 5% critical value at 5% is always less than critical value at 1%. So sorry, this is my mistake. Just reverse. Critical value 1% level is always okay. I am correct. Critical value of 1% is always greater than critical value of 5% level. So if a observed F is smaller than the 5% level, it is obvious that observed F should be smaller than at 1%. Critical value at 1%. Okay, so that's why I write this thing. If this method is insignificant, because the observed A for methods of planning being smaller than critical value at 5% level, this implies these methods of planning is insignificant. Methods of planning is insignificant at both the levels. Both the levels means 1% and 5%. Okay, can I repeat this thing? Follow me. See that critical value at 1% level always greater than critical value F at 5% level. So if observed F is less than critical value at 5% level, it is obvious that is observed F also less than critical value at 1% level. So if it is significant at 5% level, it is also significant at it is insignificant at 5% level, it is also insignificant at 1% level. That's why I write this thing, methods of planning is insignificant at both the levels. Okay. But the observed for date of, sorry, this is mistake, this is planting, not planning. Okay. For method of planting, it's changing planting. So observed for dates of planting is greater than if 0.01 1,6, that means 9.78, and hence is significant at both the levels. Okay. So one thing I forgot to mention, before starting all the calculation, after model here, after this line, you should write the hypothesis. I forgot to mention to write this thing. Please write this thing. H0 1 null hypothesis. This is correspond to method alpha 1 equal to alpha 2 equal to alpha 3. That is, all the methods are additional effect of all methods equal to 0 versus alternative hypothesis, at least one alpha I not equal to 0, and H0 2, this is correspond to date beta 1 equal to beta 2 equal to beta 3 equal to beta 4 equal to 0 versus H 1 2 at least 1 beta I not equal to 0. This is null hypothesis. This is null hypothesis. These are alternative hypothesis. So since here the observed wave of the method of planting being smaller than this means we fail to reject H0 1 at 1% and 5% levels, and hence and here H naught means corresponding to the method. Okay. And here observe if is greater than 9.78. This means we reject H naught 2 at 1% and 5% levels, and hence it is significant at both the levels. And this indicates that the different method of planting is different methods of planting affect the mean yield of sugarcane in the same manner. But the mean yield differs with different dates of planting. Now, the next question is, if the I think it is better go to the next slide. If the 4 dates of planting included in the above experiment is the only dates in which we are interested, then the next question that arises is, which one of the 4 dates will give us the maximum mean yield. To answer this question, we compute the critical value. Actually, we apply post hoc test, compute critical value at 5% level. I consider 5% level of significance, that is equal to critical difference, because all the, this is a balance case, because under each method number of observations same. So critical difference value, or we call it least significant difference, LSD, or critical difference CD value, this significant critical difference or this significant difference value at 5% level of significance, which is equal to T 0.025, comma error degrees of freedom, that is 6, into here 2 MSC by N naught here it is 3. Okay. So please compute this value. According to my calculation, I get this value is 1.48. Please check. This is a critical value of T distribution. This is the upper percentile to upper 2.5 percentile point of T distribution with 6 degrees of freedom. From T, you can use T table or you can use R code, that is QT 0.9756, and if you want to round this value, round QT up to say 3 decimal place, and I get this value is 2.447, and after using this value MSC, then I get the LSD or CD equal to 1.48. Okay, please check, follow me. Then now we arrange four date planting in decreasing order. Then first I get October, that is 8.56. We should write this here. We arrange the mean yield meaning of sugarcane for the 4 data types. So this is nothing but a, just go to the slide. So this is a 25.69 by 3. Then you get this value. February, that is E01 by 3. This is 4.73, which is T02 by 3. In November, 4.02. I think I denote February by, this is T03. Okay. This is T02. November is T02 by 3. March. Okay. Okay. Thank you, Paulumi. No problem. Thank you very much. So according to you, it should be, no, after rounding it is 1.48. Your calculation is correct. Either you, according to me, because I want up to 4 decimal place, that's why you write. Okay, thank you, Paul. So if you want 2 decimal place, that is 1.48, or you can use 1.477. Because these are all 2 decimal place, so that's why I use 1.4. Okay, if it is 4 decimal place, it is mean value, so then you can use 1.4772. No problem for you. Okay, it's okay. March, this is 2.12. T04 by 3. Now, I denote October by, mean of October by x01 bar. This is x0 or not 3 bar. This is x02 bar, and this is x01 4 bar. X04 bar. Okay. Now find this value x0 bar minus x02 bar. So you see that this is greater than 1.48. x0 1 bar minus x0 3 bar. This is again greater than 1.48. x0 1 minus x0 4 bar. This is again greater than 1.48. x0 2 bar minus x0 3 bar. This is less than 1.48. x0 2 bar minus x0 4 bar. And this is greater than 1.4. Okay. So from here we see that February and November, from here we see that February show no significant difference, but their mean is significantly less than that for October and significantly more than that for March. So from here we see that we can conclude that thus we find that October gives the maximum yield and March the minima. So your recommendation is you can use any method, but you should plant on October only, because on October you get maximum yield. Okay, so this is the way how to analyze this data. Okay, so have you any question? Please tell me before going to the next part, that is 2A Anova more than one observation parcel. So Polomi, please tell me. Anushka, Polomi, Porobi. If you have you any queries, please tell me. If not, then I go to the next. Okay, last part means, okay, so first you compute this critical value. Okay, that is the critical difference. I think you can understand this for. After that, you compute x1 bar, x2 bar, x3 bar, x4 bar. Now you arrange the mean according to decreasing order. Then you get October, February, November, March, because October has a maximum mean, then February, then November, then March. Now you compute this part. From here you see that October are significantly different from February, November and March, because x1 bar minus x2 bar greater than 1.48, x mod x1 bar minus x0 bar greater than 1.48, x0 1 bar minus x0 4 bar greater than 1.48. But February and November is insignificant because of this, but February again significantly different from March. And I forgot to mention one thing here, that is x naught bar minus x naught 4, which is again greater than 1.4. So February is significantly different from November. February is significantly different from March. But November and February and November, they are insignificantly different. So, but according to this arrangement, we can say that February and November show no significant difference. Why? Because this. But their yields, November and February, is significantly less than for October, because October is has maximum mean yield. And it is significantly more than that for March, because March has minimum mean yield. Thus, we can conclude that October gives maximum mean yield and March gives minimum mean yield. Clear, Paulumi? Okay. Now, I think it is clear. We can conclude that October gives maximum mean yield, March gives minimum mean yield because of this, and the recommendation is we should use October for planting, because, and use any method. Because why any method? Because we already see that there is a insignificant difference in the methods. You see that line, the observe paper method. So this method of planting is insignificant. So we can use any method, but we use October for planting. Okay. Okay. Thank you. So can I stop here or go to the next computations? Please tell me. Can I stop or go to the next computation? Follow me. Please tell me. So I think, so please tell me, follow me, Anushka, Korobi, please tell me, can I stop here or go to the next part, that is 2A Anova? Okay, proceed. So here, first you need to compute. Here we see that there are two factors. One is spacing and another factor is variety. Spacing has 3 levels, that is S1, S2, S3, and variety has 5 levels, 5 varieties, V1, V2, V3, V4, V5. And we see that each cell containing more than one observation, that is here it is 4 observation per cell. So we use 2A Anova more than one observation per second. Now, here Yij Yijk denote the yield of the kth plot for ith variety at the jth spacing. Here I from 1 to 3, 1 to 5, j from 1 to 3, k from 1 to 4. Then the model is Yijk mu plus alpha I beta j plus gamma ij plus Eijk, where mu equal to general effect, alpha equal to additional effect due to ith level of ith level of variety or ith variety, beta j additional effect due to jth spacing, gamma ij interaction effect due to ith level of or ith variety and jth spacing. Eijk equal to random error corresponding to Yijk. So please compute this part. These are the homework. I just sketch the computational process for this problem. I think you can do it yourself. So I from 1 to 5, j from 1 to 3, k from 1 to 4, Yijk. This is a grand total. CF, this is correction factor, which is P naught naught whole square by n, where n equal to number of plots, that is 4, number of varieties, that is 5, number of spacing, that is 3, that means 60. Now compute Ti naught naught bar, which is equal to j from 1 to 3, k from 1 to 4, yi jk, where I from 1 to 5. So you need to compute T naught naught, T1 naught naught, T naught, T2 naught naught, T3 naught naught, T4 naught naught, T5 naught naught. Then compute T naught J naught, which is equal to I from 1 to 5, k from 1 to 4, yi jk, where j from 1 to 3. So this compute following T naught 1 naught, T naught 2 naught, T naught 3 naught. Then compute Tij naught, which is equal to k from 1 to 4 yi jk for all I from 1 to 5, j from 1 to 3. So here you need to compute 15 these values. So please compute this. Then SS due to total SST, which is equal to I j k yi j k square minus correction factor with degrees of freedom, that is n minus 1, that is 60 minus 1, 59. This is due to varieties. This is equal to sum over I pi naught naught whole square divided by m cube. M here is 4, q is 3. So I from 1 to 5. So this is 4 into 3, that is 12. That is 4 into 12. 4 into 3, sorry, minus correction factor with degrees of 2. Five minus 1, that is equal to 4. This is due to, actually you remember this thing, you should, the divisor you should things, I think I want to say, actually when you divide it 12, 12 means this is just you write the label. Suppose there are m observation parcel, p label of p for 5 and q for 3. That means p is a number of labels for varieties, q is a number of labels of spacing. So in that case you should divide this by np. So just ignore 5 because I from 1 to 5. So you ignore 5 and divide this by the remaining part, product of the remaining part, that is mp, which is 12. Okay, sorry, mq, which is 12. So S is due to spacing which is denote this by SS capital V, SS SP, which is equal to sum over J P naught J naught whole square, and here J from 1 to 3, that is Q, it should be MP. MP means 4 into 5, that is 4 into 5 is 20. Okay, minus correction factor. With degrees of freedom 3 minus 1, this is 2. This is due to interaction. Summation ij Pij not whole square by M, that is 4, minus correction factor minus SS D minus SS S with degrees of freedom, that is 4 into 2, that is 8. I denote this by S E cross S. So SS due to error SSC SST minus SSV minus SSSP minus SSV cross SP, and with degrees of freedom, that is 59 minus 4 minus 2 minus 8. Minus 4 minus 2 minus 8. Okay, so now we compute MS, which is MS V, which is equal to SS V by degrees of freedom, that means 4 MS SP degrees of freedom SS SP by 2 MS V cross SP SS V cross SP by 8 MSC SS E by error degrees of freedom. This is denoted by DF error. So DF error. And we know for fixed effect model to Anova, MSC is a valid error. So we compute F1, which is a F ratio corresponding variety, MSV by MSE, F2, which is a F ratio of corresponding spacing, and F3, which is a F ratio corresponding interaction. Now we construct Anova table for this case. We need to add one more slide here. Okay, so okay, fine. So now Anova table. That is, first column is source of variation. Degrees of freedom. Source of variation, first component, due to variety. Due to spacing. Interaction. Error. Next paper. So please write degrees of freedom, that is, it is 4, 2, 6, 45, and this is 59. Please write the value of SS here, MS, and then F, and according to my computation it is 10.469. Please check, these are the homework. 2.099, 4.206. This is corresponding to the interaction. And F at level 1% and 5%. For this, I think you can compute this value, or you can find this value from the table. Please check this value. 5.13, 3.21, 2.95, 2.16. For 2A Anova, I already discussed this situation. 2A Anova more than one observation factor, fixed effect model. We should test interaction effect first. Okay. So one thing I should mention here also, I forgot to mention, that is null hypothesis. Here we first test the null hypothesis, that is gamma ij equal to 0 versus H11, that is gamma ij not equal to 0, at least 1 ij. If this hypothesis is accepted, that means if we fail to reject H0, if we fail to reject H0 1, then we proceed further, that is H0 2, alpha 1 equal to alpha 2 equal to alpha 5 equal to 0 versus H1 2, that is at least 1 alpha not equal to 0, H0 3, beta 1 equal to beta 2 equal to beta 3 equal to 0 versus H13 at least 1 beta j not equal to 0. Again, I repeat this thing. If interaction effect is absent, then you proceed for testing H0 to H03. Otherwise, you stop. So here we see that the observed for interaction is significant. Why? Because the critical value is less than observed at 1% level. That means it is also significant at 5% level. So hence we do not test for the effect. For the effects of varieties and space. One thing I should mention, in case if you get interaction effect is insignificant, then you proceed further. That is, you need to test whether the main effect variety is significantly different or not, or main effect spacing is significantly different. And if you find variety is significantly different, suppose variety is significantly different, in that case we proceed post hoc test. That is, I already mentioned this test. In that procedure you can proceed. Similarly, if your spacing is significant, one thing you should remember, if interaction effect is absent, in that case you proceed to test main effect of spacing, main effect spacing and varieties. And if you find that the varieties is significantly different, in that case you proceed which variety is responsible or which variety gives maximum yield. For answer this question, you need to proceed these steps. Okay. Similarly, for spacing, for which spacing is responsible for the if you reject or if spacing is significantly different, in that case which spacing gives maximum yield. For answering these questions, you need to follow these steps. Okay. So these are the procedure to analyze this 2A ANOVA more than one observation. So please tell me, have you any queries? And please do the computational part at home, and after finishing the computation, please submit it. You can send me, you can send this via mail. Okay, you can mail me. So please tell me, follow me, have you any queries? Otherwise I close this stream. Follow me, Anushka, Korobi, please tell me, have you any queries? Otherwise I close this stream. So in my next class, we will discuss 2A ANOVA random effect model. Okay, so Please tell me, have you any query? Have you any question? Okay, thank you for learning. So in the next day, that is the coming Monday, at the same time 6 p.m., we will discuss Ran 2 Anova random effect method. Okay, thank you.